Alright, as I mentioned last time, I want to take a look at sort of some more wrinkles in these counting methods that we've been establishing so far. And I've always found it useful sort of to fall back on an example we've already considered. Also, it means I need to come up with fewer examples, so coming up with fewer silly things to end up basing this stuff on. Anyway, so we've mentioned previously I was wanting to have the class put on a Cary Grant movie marathon where we picked out 6 of his films and we were going to show them. All right, so this, as a result, should end up looking kind of familiar, right? We had this laid out previously. What I'm wanting to consider now is what happens if we don't have as much time as we thought. It turns out that there were some issues with the reservation system or whatever. We need to share the space with somebody else, and so we don't get to show all 6 movies. As it turns out, we're only going to have enough time to show 4 of the 6 that we picked out. So how is that going to end up changing things? Well, with it laid out like this, it's relatively straightforward, right? If we only have time to show 4 movies, whoever ends up in these 5th and 6th slots, sorry, yeah. So maybe there's some argument over which movies end up getting the boot. It's basically the same argument that put them in the 5th and 6th places anyway. So, oh well. So those guys are gone, and the counting principle still in effect for the remaining 4 movie slots. Times. And so now we'd have 360. So, you could just divide the value we can with the 4 by 2, because that's the only thing that's really different. So we have 360, call it a mini marathon now. So that's, those are our options at this point. So sort of like we saw previously with the factorial, this ends up coming up often enough that mathematicians have given it its own name. So in this instance, what we're going to be talking about is counting what we call the number of permutations of objects that we grab from some sort of bigger set. So permutations. Yeah, so we can do this, it's built around using factorials. If you look in the PowerPoint slides, there's a formula there, but I don't expect you to use that formula, because as we said before with the factorial, I'm taking for granted that you've got a calculator that has some kind of, feature. Generally, if it'll do a factorial for you, it'll also count permutations for you. So for what it's worth, the format here, the way we would normally write this, the way the notation this ends up looking like, is we've got like a little subscripted 6, then the capital P. So this is how many things we're choosing from. This is how many of those things we're picking. So this should pretty much always be no bigger than the number that's in front. Like 6P12 doesn't make sense. Anyway. So, like I said, there's a formula. You could use it if you wanted to. There's, I would recommend doing a whole lot of arithmetic, canceling of terms, so you don't, overflow your calculator. Factorials, in case you haven't already observed, they get big really fast. Anyway, so I'm going to do this using my calculator. Let my fingers do the walking here. So we need 6P4. So type in my 6. So I got my 6 in there. Trying to figure out how to rotate this. 6, yeah. All right, so just like before, the thing we're after is in that same math menu that we looked at previously, math, then we'll use the arrow keys to slide over that thing labeled PRB, and you'll see, hey look, number 2 looks like NPR, go ahead, National Public Radio jokes. Scroll down to that, hit enter. You do want it arranged this way, so you want the N first and then the R that comes after it. So I had 6P4, that's what it looked like in my calculator. If you have a scientific calculator, that's probably a similar sort of PRB labeled menu in there that you'll want to find that in if it's not just like the shift function of one of the basic keys. So we hit enter, and lo and behold, 360. Just what we came up with, just by using the counting principle here. So it does end up kind of expediting things if you're just able to say, well, I need to pick 4 objects out of a group of 6. So, 6P4, that's, kind of, how we can end up laying this thing out here. So, by the same token, I want to take a look at one of our other previous examples. Like I said, I try to get maximum mileage out of these things, so I don't have to come up with a lot of different things to say in class. So coming back to what we, the other example we saw last time, we have 8 horses lined up in a race, right? Okay. So we have 8 horses, and before we worked out that there were 8 factorial, or 40,320 different ways all 8 horses can cross the finish line. For what it's worth, most horse racing folks, they don't particularly care in a situation like this who finishes 6th or 7th. Again, maybe if you own the horse, it matters to you. But generally speaking, they're probably only worried about like the top 3 finishers. So if I remember right, again, I'm not a horse racing expert, but I think they call it win, place, and show, or the titles given to the horses that cross the finish line first, second, and third, respectively. So again, you could do this using the counting principle. There's nothing wrong with doing like having win, place, show boxes and then sort of working through like we did before. However, we don't really need to do that because now we know, well, we have 8 horses in our, I always describe this as objects in a bag, and then you kind of pick them out one at a time. I would not recommend putting 8 horses in a bag. That's a really big bag, and you're going to have some very angry horses. But, so in this instance, we're sort of picking one horse to finish first, then another to finish second, then another to finish third. So you could use the fundamental counting principle, or we could work out 8p3. Like I said, I've let my fingers do the walking already, so I won't pretend that I haven't already done the calculation. So as it turns out, we would have a total of 336 win, place, show, results. I don't know why I'm compelled to label that in there. So win, place, show, first, second, third, whatever you want to call it. So we talked about the the racehorses thing. So all right, that having been considered, I want to take a look at one more example here. So I like bringing this up. So this one is actually new. We haven't already talked about it. So we got 12 people, and they're in a club. So for what it's worth, every time I write this, I end up thinking I really need to rephrase this. When I say club, I mean organization in this instance, because what they're going to do is, they want to elect their president and their vice president for the year. So in this case, like I said, organization makes sense, although I can't help but find it amusing that imagining 12 people in a dance club and like one of them leaping up onto the bar and declaring himself president of dance. So anyway, so sorry, like I said, these things pop into my head and I have to get out or my head will explode. So we've got 12 folks in this organization and 2 positions to fill. And again, you don't want the same person filling both jobs because the vice president's big thing is to do the president's job. The president can't be there, right? So again, we could do this with the counting principle. There's nothing wrong with Pres, VP spots, and then working things out that way. But since we've got this new tool, what is it they say? When all you got is a hammer, everything looks like a nail. So we've got 12 people from whom to choose, and we've got 2 spots to fill. So 12p2. If you work that out, and you would get the same result if you were to use the counting principle. You get 132 different ways the organization could pick its, leading officers. So, all right, so that's some counting permutations. As I said, there's a formula in the posted PowerPoint slides, but I don't generally expect you to use it. If you said the Math 107 takes for granted you've got a calculator with the horsepower to do this for you. So, figuring out, how you want to arrange these things is the real heart of these problems, not smashing through how the formula ends up working out. All right, so still not quite done with our counting techniques. There's one last wrinkle I want to consider, but the last couple of videos were a little long, so let's make this one short.